packaging. Thanks for joining us today. So when we're talking about packaging, it comes in many forms. So you can see here I've got some examples: a corrugated envelope, bottle, can, carton, etc. When we're looking at these packaging types, we've got different images on there. So you've got the names, the dates, batch codes, serial numbers. It could be variable data, it could be fixed data. And especially when it comes down to languages, because on the bottles you can have hazard labels in multiple different languages. So you want that label to actually fit to that language form. So once you've designed it, you can design it exactly right. What I'll be talking about today is 3 examples of software. So here we've got Hybrid's PAC software, Meteor's eLab Pro, and Meteor's MetPrint. Here are some examples of Meteor customers' demonstrations for packaging. So they're doing direct to object, or they're printing onto a label, which is then transferred onto the packaging. So when we're looking at the requirements for a PDF to packaging, I've kind of listed a few here, 12 points. So I'm going to go through 6 on this slide, and the other 6 I'm going to follow on the separate slides. To start with, I thought with PDF editing being a main requirement. So we are going to be able to look at a PDF file that's already been made by using something like Adobe Illustrator or GIMP, if you're looking for some freeware, and being able to actually look at that PDF in detail. Then there's the variable data printing of EDP prepare. This is where, again, you're looking at the QR code, the barcode, the dates, the batches, timestamps, etc. Then we've got a step which is gravure. It's a little bit off, but gravure being the engraved rotating cylinder. And the way that digital comes into this in more recent years is that you can digitally engrave by printing onto a flat sheet and then wrapping that around a cylinder. This kind of information can be extracted from the correct software. So something like Hybrid Steps and Packs can export that data. Then we've got the cut line definition. So looking at the cut line, we're talking about the slicer and the slitting machines, which are further down the line. Again, we could export this data at the point when you're doing the preparation of the PDF, or you could export it after doing the RIP. And certain RIPs, such as eLab Pro, could extract that data and export it as different image file types, BMP, JPEG, that kind of thing. Then we've got VDP execute. So this is where you're taking a design such as a label and doing it multiple times and picking up a CSV file or an XML file to produce those barcodes and labels and different types of data across all those labels on a sheet, and actually being able to manage that sheet and the positioning of each of those labels. And at the bottom there, we've got barcode assets. So these are the typical barcodes that come around in the digital or analog industries, and they're covered by many types of software. You'd want these to be covered within the software you're picking up for the PDF preparation. So Hybrid Steps and Packs obviously picks up most of the industry standards. So now we're looking at wrapping. So this is the application of the image format around a 3D object. And you'd want to do this for pre-production purposes, so that you can see that the label is correctly configured and designed to fit around the actual packaging that you're going to apply it to. Then we're looking at the pre-flight. I think is a very important step with the pre-flight information, where you're looking whether the image has a low resolution, if it's in the right color space, etc. And if it is in a lower resolution, are you able to easily swap that image out for a higher resolution of image or a different image altogether? And that's where in Hybrid Steps and Packs you can actually access images such as TIFF, EPS, JPEG, PSD to just swap those images in and out. The other aspect of a PDF prepare is to be able to detect a barcode from a pre-created PDF. So this is where a barcode has actually been flattened or vectored. And then to be able to detect that barcode and feed the data into it from a CSV or an XML file, and alter the bar widths or the padding that goes within that barcode. Therefore, it's easier to read in the digital printing environment. So the types of barcodes that can be detected, or the typical ones in the industry, would be the EAN or the ITF barcode data. Here we're looking at the transparencies of the images and making sure that the multi-page PDF can be picked up by the PDF prepare software for the packaging. And also looking into the varnish layers, if they're generated by the software post this process, or if they can be done right now. And in packs and steps, we can actually pick up those images and create that varnish layer or the under white layer at this point. There's also a process here where we can place in tools such as the station numbers or the corner marks, or even having something like the alignment and the color strips. Calculating ink consumption is important to the users. So if you're looking at how much ink is being produced from that actual label, you can estimate that on the ink consumption charts, and then adjust for the colors if needed. There's also, if you notice on here at the bottom, is a dye, which is a technical layer. That could be exported at this point, or it could be picked up by a RIP at a later point to save you having multiple documents for the same production. Sorry, didn't work. There we go. Right, here's an example of a typical layout of a label. And what we've got here is a number of objects we group together, and we call them the assets. So we've got a media box, a crop box, a bleed box, and a trim box. So your media box is basically your page size. This is what's going to be defining the actual size of the print or page or web as it goes in. Then you've got your crop box. So anything outside of this crop box region will be lost at the point when you're putting it through. Then we've got our bleed. Our bleed box is where the image design has gone past the trim, and I'll come back to the trim in a second, where if you've got any misregistrations within the design, it's taken care of by the bleed box. And the trim is what you're really fixed on. That is the size of the label in the end. Anything outside of this trim will be lost at the point of the production stage. So then looking at the PDF options, so whether you want a high quality PDF, so what we're looking at there is typically what we're calling composite. So you're including the spot colors along with the other colors at CMYK. You may want to export the PDF without the spot colors just to give you the protection of the image when you take it to the design house. So the initial steps of taking it there to the customer to do the initial print designs, and you don't want to give them all your IP. Then compliance with the latest standards, so something like the PDF X4 standards, that's within the steps and packs software, and is probably vital at this stage when we're looking at pushing the industry to a point where everyone is focused on the same output. The color space, whether it's RGB, CMYK, or if we're looking at spot colors. The separations, here I'm mentioning more about varnishes and the layers of embossing or a hot foil. And then transformations, if you're rotating the images or you're flipping the image in this part of the design. And then distortion, so you may want to shrink the design down by a factor, typically 2%, if this is going into a flexo plate. And here are some export PDF options. So image compression, this is all really to reduce the size of the PDF file. So whether you're downsampling from the native resolutions, so if you've got an image that is 2400 dpi and you want to output 600, that's going to be much better for the size of the PDF on the output file. Then if you're clipping images, so images outside of that clipping boundary as I mentioned earlier, if you want to vectorize strokes, so instead of having a stroke that can be totally editable, there's a way you can vectorize that line and then put it back into hybrid steps and packs and be able to pick that up and edit it at a later date. And another mention here is vectorizing text. I'm not sure if I mentioned earlier, but text can be picked up by the steps and packs software as a vector or by an embedded font. And then we've got the RIP handling of the PDF. So this is after the PDF has been exported, and now you're into the RIP. What parts of that can be actually helpful for the RIP? So making sure you've got your layers in the correct way for the image separations. Your RIP could then export the data down to processes further down, like in inspection cameras, etc., or dies and cuts, slitting marks. And then we've got the section of page export, so whether you're selecting to export the whole PDF or just regions of it, and the image resolution. So even though your PDF could be at the right resolution of 600 dpi, you may have a number of different presses running 400 dpi or 360 or 600. After this point, we're on to the drive electronics, which brings me to this slide. This is the Meteor group who work at Harston. Meteor have 5 other offices across the world, so we're in Korea, Japan, China, Germany, and Florida in the USA. And this is how Meteor fits into the hybrid software group, along with Global Graphics Software, Hybrid Software, Zytron, and more recently, the Color Logic group. Thank you very much for your time today. Thanks.